Okay, for number 10, we have a force, I guess this is number 10. Yeah, we have a force of 85 newtons exerted at an angle of 35 degrees above the horizontal, and it's required to move a washing machine. So here I have the force. Okay, so it's kind of through it, but whatever. If the washing machine needs to slide 15 meters up a ramp, how much work is done? So we would go back and we would look to see that we would use the projection formula. So the projection formula says the work amount done is the projection of F onto the distance vector AB, and then times the magnitude of the vector AB. Okay, so put a dot there. Okay, so now we have to do the projection of F onto AB. So we need to use our trig cosine there. So we have this triangle. I'm going to pull this triangle out. We have 35 degrees here. We have, this is the projection right here. Okay, projection of F onto AB. And here's our F. Okay, and so if we look at the cosine of 35 degrees, that's equal to the projection of F onto AB over the force vector, the magnitude of the force vector, which is 85. But we can just put F here if we want. Okay, so 85. Well, we can just put 85. Pop. I'll just put F because we're just using all numbers here. So the projection of F onto AB is equal to the magnitude of F times the cosine of 35 degrees, which is equal to 85 times cosine of 35 degrees. So if you punch that into your calculator, you get 85 times the cosine of 35. I got, 69.6279 ... right? Keep going. And then, remember up here, we had to multiply the projection to get the work times the magnitude of the distance, which would be, how far do we push it? 15 meters? So 15 meters. So multiply that by 15, and you get 1044.42. I just didn't round it here because I wasn't done. So 1044.42, and then you would use work joules. Okay? Joules. So we have newtons and meters, and we have joules. So that would be the answer to number 10. And let's move on to number 11. Okay, number 11 says, Anna's pulling a wagon with a force of 75 pounds. If the handle of the wagon makes a 40-degree angle, okay, so we have this little wagon. Those are the wheels. We have this wagon. She's actually would be pulling from up here. I'm a terrible drawer, aren't I? Okay, wait. Let's draw the wagon first. So here's a wagon. Here's a wagon. And here's the handle. Okay, there. How about that? So here's the handle of the wagon. If the handle of the wagon makes a 40-degree angle with the ground, and the wagon is pulled 50 feet, so actually, I guess the wagon's all the way, I don't know. What do they mean to the ground? How could we have the handle making a 40-degree angle with the ground? Guys, just draw it like I drew it. You're going to get the right answer. With the ground meaning like horizontal, okay? And the wagon's pulled 50 feet. So we know AB. The magnitude of AB is 50 feet. how much work is done. Okay, so let's do using the dot product. So the work is equal to the dot product of the force times the vector AB, and we can get both those vectors. So the force is at an angle, so we have to do how much 75, so F is equal to 75 cosine 40 and 75 sine 40, and vector AB is just across the ground, right? So that would be 50 on the X and 0 on the Y. All right, and so you can see, because it has that 0, it makes it so much easier. So the dot product would be 75 cosine of 40 degrees times 50 plus 75 sine of 40 degrees times 0. So all I have to do is figure out that. So 75 times the cosine of 40 degrees times 50 gives me 2,872.67. Okay, this is foot-pounds, right? Foot-pounds. There you go. There's your homework.